Alright, hello. We're going to be looking at two numbers today, 0 and 1, that you're probably not terribly shocked are a little special in math. So let's see some of the things that make them so special. Alright, so the goals and objectives for this lesson are sort of properties of 0 and 1, and then we'll use that to get into possible and impossible values of a variable. What do I mean by property? For purposes of this class, something's a property because I say it's true, and hopefully you agree, either because it seems like it's common sense or you could have figured it out by itself. It's self-evident. So it's a mathematical statement known or agreed to be true. The word axiom and the word law are sometimes used in other math books in sort of similar ways. So here are some properties of 0 where x is going to represent any real number. You're not hopefully terribly shocked to find out that when you add 0 to a number and the order doesn't matter, you get the same number back. Subtraction is a little trickier. 0 minus a number is the opposite of the number. A number minus 0 is still the same number. Resist the urge to read that there as negative, because remember, you don't actually know if x is a positive or negative number. So 0 minus x is equal to the opposite of x. Multiplication. If you take 0 and multiply it by a real number, order does not matter, you're going to get 0 as your answer. Even more useful, perhaps, if you take two numbers and multiply them together, where x and y are real numbers, and you get 0 as the answer, that implies that either x was 0 or y was 0. Or it could be that both were 0, but the idea is that when you're multiplying real numbers, the only way to get 0 as the answer is if you start with 0. Division is a little trickier. First off, we got to be sure that we're clear that x is not 0. It's a non-zero real number. If you know that x is a non-zero real number and you divide it into 0, you get 0 as the answer. Also, division by 0 is undefined. So you can't divide by 0. If I ask you a question that causes you to try to divide by 0, the correct answer is undefined. I would take impossible, but it would be nice if you would write undefined instead. So let's pause there and work a few problems real quick. So here we go. 0 plus negative 5. Well, any number plus 0 is the same number. So negative 5. Sorry about that. I'm not sure if you all heard the doorbell or not. It was somebody doing the fundraiser. Alright, so what about 0 minus 7? Well, the rule for 0 minus a number is that it's the opposite of a number. So since we're subtracting 7, the answer here is the opposite of 7, which is negative 7. 3 times 0. Well, anything times 0 is 0, so 0. Slightly more complicated, but does it really matter how scary the number is here? You're multiplying it by 0, so what's the answer? 0. Same deal, scary looking thing we're dividing by, but we're dividing it into 0, so the answer is 0. And then the trickiest one, negative 17, divide by 0. Well, division by 0 is undefined. Alright, so I think we got our arithmetic involving 0 down. Let's look at some properties of 1. Now, I want to point out to you that I've switched things up here for just a second. For addition and subtraction by 1, I want to talk about if n's a natural number. So a much more limited set of numbers. The idea is I want you all to understand that when you say n plus 1, it's like you're saying next number, which a fancy word for that would be successor. Subtraction, if you say n minus 1, then that's like saying previous number. And a fancy word for that is predecessor. So if n is a natural number, n plus 1 would be the next number, n minus 1 would be the previous number. If you do this real quick for a specific number, you're not terribly shocked by this. If n is 13, then 13 plus 1 is 14 is the next number. 13 minus 1 is 12 is the previous number. I've just had students have trouble in the past with visualizing this idea that n plus 1 is the next number, n minus 1 is a previous number. And then we're back to real numbers. So if x is a real number and you multiply it by 1, it doesn't matter what order you multiply in, the answer is going to be that same real number. And if x is a non-zero real number, then x times 1 over x is the same as 1 over x times x is 1. And think of it as the x's are canceling out. Division, well, if you divide by 1, you get x. It doesn't change the value. This one was a little more complicated just trying to get it set up, and I realized that this would hopefully work pretty well for you all. If x is a non-zero number, then 1 divided by x. Notice that I use sort of the more old school division here. Sometimes I have to do this when I need to emphasize something. 1 divided by x is equal to the fraction 1 over x. And so you can think of it as, what's this sort of symbol mean, or what's this mean? They are the same thing. 1 divided by x and 1 over x are the same thing. So let's go do some properties of 1. 3 plus 1 would be the next number after 3. Well, the next number after 3 is 4. 21 minus 1 would be the number before 21. Well, the number before 21 is 20. Kind of a scary looking factor here in our multiplication, but you're multiplying by 1, so the answer is still just 382. Oh, 17 times 1 over 17, those cancel, leaving 1. 1 divided by 5. You know what? I may have left this one over here out of the PowerPoint, but that's okay. We'll go back and add it together real quick. 1 divided by 5 is 1/5. We can change the division to the fraction. 13 divided by 13. Well, a number divided by itself that's a non-zero is going to equal 1. I think I accidentally left that out. So let's real quick add that to the PowerPoint. Got here. Move that up. And I need to insert object, Microsoft equation. So this is letting you all kind of get a sneak peek on how I do some of this stuff. X over x equals 1. Insert that into our slide, shrink it down to a more reasonable size. And I'll have to clean it up a little bit better than that later, but it gives you that idea that when you take a number and divide it by itself, you get 1. The exception to this rule is still that problem if x is 0. So you can't divide 0 by itself and get 1. That'd be a problem since you're not allowed to divide by 0 in the first place. Alright, I made a little note there to myself to go back and fix that later. So, all that really leaves is we want to look at some possible and impossible values. Possible values. Well, what number could you add to 2 to get 0? Well, sort of the way this works is this would have to be the opposite of 2. So the opposite of 2 is negative 2. Okay, well, what number could we multiply by 3 and get 0 as the answer? Well, according to what we just talked about with 0 and 1 today, the only option here is that x would have to be 0. Okay, this one's a little trickier. Excuse me, think of it in two pieces. we got something times something equals 0, then one of the somethings has to be 0. What would make this something 0? Well, it's kind of like the problem right here above it. What plus 3 would be 0? Negative 3. Well, what minus 2 would be 0? Positive 2. And so the final answer here is that x could be, the possible values here are negative 3 or 2. And there's no way to know for sure which one it should be. And of course, x can't be both at the same time. When you put negative 3 in for this x, you would get 0 times negative 5, which would make 0. If you put 2 in for x, you would get 5 times 0, and 5 times 0 would still be 0. And so there's two possibilities here. This is a similar problem because I feel like this is a skill that some of you, if you have seen before, you might still need to work on a little bit. Hey, what could you add to 5 and get 0? Well, the possibility there is negative 5. What could you subtract from 5 and get 0? Well, the possibility there is 5. And so here you have that x is either negative 5 or 5, and there's no way to know for sure which is true, but if you check either one, you're going to get something times 0 or 0 times something. And so that's kind of how possible values work. Notice what's true about all of these problems is, oops, I meant to do that in red. Every single one of them works the way it does because it was something equal to 0, which kind of pins down possibilities. Impossible values. Well, remember we said we can't divide by 0. So since we can't divide by 0, we don't even honestly, it's just there to mess with you. It doesn't matter what any one of these numerators is. Just completely ignore numerators. Focus on denominators. Okay, what would happen that would make 7 minus x 0? Well, that would be if x were 7. If x were 7, then 7 minus 7 would be 0. So what we say is that x can't equal 7. Well, what would happen to make 8 plus x equal to 0? Well, the only way these would add to 0 is if they were opposites. And so x would have to be the opposite of 8, which is negative 8. That's what would make the numerator 0, but we can't have that happen, so x cannot be equal to negative 8. For that particular expression, x being negative 8 is impossible. And then this one's kind of like the ones from the last slide. There's going to be two options. X cannot equal, well, that would be 0 if x were 3, so x can't equal 3. Or we got another option over here. What would make x plus 1 0? Well, that would be the opposite of 1, which is negative 1. And so here you have two impossibilities. X is not equal to 3, and x is not equal to negative 1. Alright, that is it for now, I believe. Hopefully this made sense to you, and I will see you next time in class or on the next video. Thank you very much. Bye.